Okay guys, in this video we're going to be covering area of a circle. I'm going to briefly explain where the formula for area of a circle came from, and then I'm going to show you a couple of basic examples before we get into the tougher ones. So first, if you take a circle to calculate its area and cut it into 8 slices, and then turn those slices into a parallelogram, it has a little bit of a bumpy surface, but if you average that into a straight edge, it would actually form a perfect parallelogram. And the height of that parallelogram would be the radius of that circle. The base of that parallelogram would actually be half of the circumference, because remember, I put 8 slices on the bottom, or 4 slices on the bottom and 4 slices on top. So half of the distance around the circle is actually the base of that parallelogram. If you can remember, the circumference formula is pi times diameter, so half of that would be pi times the radius, which is half of a circumference, pi times the radius. So if you can think about it in terms of, well, if the base of this parallelogram is pi times the radius and the height of this parallelogram is the radius itself, then I would find the area by doing base times height. So I would do the pi times r, which is half of the circumference, times the height, which is the radius. And if I multiply a radius times a radius, I get a radius squared. And that is the area formula for a circle. It's pi times the radius squared, and that shows it to you in terms of if you use it as a parallelogram like that. You cut it into 8 slices, form a parallelogram. Half the circumference is the base and the radius is the height, so it's pi times radius squared. Another way to think about it is if you take a circle and you take the radius, the circumference is 2 pi r, and you broke it down into like a pyramid. And that pyramid, it has a base. It's basically a triangle, and the base of it is the circumference of the circle, right? Because we unfolded it to be a triangle or a pyramid of sorts. So the base of that pyramid is pi times diameter, or 2 times pi times the radius, right? That's the circumference formula. That was the base of our triangle. The height of that triangle is the radius of the circle. So to find this, and remember, it's an area of a triangle here. And those jagged edges you could fill in to form a perfect triangle. To find the area of a triangle, I would do 1/2 base times height. So I would do half of the circumference, right? So half of 2 pi r times the radius, and you can see the radius times the radius is radius squared, and half of 2 is 1. So that would be, again, area equals pi r squared. So that kind of shows you 2 different examples of where this formula comes from. But really you just need to understand that the area formula is pi times the radius squared. That's how we're going to calculate area. So you're going to want to write that down. Here's a couple of basic examples. So the first one has a radius of 7, and it's asking me to use 22/7 as approximation for pi. So remember, here's our area formula. Area is pi times radius squared. The radius here is 7, so we're going to plug in a 7 for the radius. Now you have to multiply, you have to do the exponent before you can multiply times pi, so I have to do 7 times 7, or 7 squared, to get 49 times pi, or 49 pi, and then now I can plug in my 22/7. Of course it's 22/7 because 49 is a multiple of 7, so I'm going to do 22/7, which is my pi approximation times 49, to get 154 square inches for my area. The next one is a 40 centimeter diameter circle. So again, I start with my formula, pi r squared. I need to get the radius. They give me the diameter, so I have to half that to get 20 centimeters as my radius, and then I can plug in 20. Again, I got to do 20 squared first. 20 times 20 is 400. And then I can just do 400 times my pi approximation. Here they told me to use 3.14, so I'm just going to plug that in, and then I'll do 3.14 times 400 to get 1,256 square centimeters. So those are just basic area of a circle. So let's look at some a little bit more interesting ones. Here I have a semicircle and I have a quadrant. So to find the area of a semicircle, and this is easier than circumference if you watched that video already, but to find the area of a semicircle arc, I'm going to start with my area formula, which is pi r squared. Here I can see that it's exactly half of a circle, so it's just going to be half of an area formula. It's half of the radius squared, So I know that the diameter is 12. I can see that in the picture. I need to do half of that to get my radius, which is 6. And then I'm going to plug in 6 for my radius. Now I have to do the exponent first, so I'm going to do 6 squared to get 36. And now I always like to simplify everything before I plug in pi, so I can even multiply the half times the 36. So I can do half of 36 is 18. And then I have 18 times pi before I plug in my approximation. Now this is telling me to use 3.14. So I'm just going to plug 18 times 3.14, and then that equals 56.52 inches squared. So again, that's half of the area formula. You could have calculated the whole area and then just halved it in the end. I try to do things a little bit differently because it helps as the problems get a little bit more tougher. So let's take a look at the second example here. This is a quadrant. So I have a quarter of a circle this time, so I'm just going to do the quarter of the area. So I'm going to do a quarter of pi r squared. Now I need the radius, and the radius is given as 14. So I'm just going to plug in 14 there. Do 14 squared is 196. And then I can do a quarter of 196, which is 49. 1/4 of 196 is 49, so 49 times my pi approximation. 3.14 will give me my area for this circle here. Now these are pretty simple. They're way simpler than circumference because you don't have to account for any exposed edges. It's really just how many square units does the figure take up, and if it's a quarter, then it's just a quarter of the area, and if it's a half, then it's just a half of the area. So we'll get into some more interesting problem solving in the next video, and I will see you then.